We begin?
Yes, ma'am.
Just a minute, I'll share my screen. Okay, so I think my screen is visible. Is it?
Yes,
Yes,
ma'am.
ma'am.
Okay.
Make it
Full
presentation mode,
screen,
ma'am.
yeah. Correct. I think that. So, good evening, everyone, and welcome you to this faculty development program. I think I have my introduction has been given, so thank you so much for introducing me. I'll come to the topic of the day straight away, where I'll be talking about YOLO and Faster R-CNN architectures. So, basically, today we are going to proceed. First of all, I will give you an overview of what object detection is, why it is done, what are the different architectures related to object detection, the background of RCNN, YOLO, why did YOLO evolve, and what was the need to go into different versions of YOLO. So everything. So in the first part, we'll be discussing everything on a theoretical basis, and after that, we will go into the hands-on of the same. That how we can actually implement an object detection model using YOLO, where I'll also be using an interface called RoboFlow and Google Collaboratory to implement the same. Right. So we'll go with the first part first, where we will be talking about the need for object detection and such architectures which will help us to detect objects. Now, I think all of us, are we familiar with the term classification and machine learning? So you can just drop a message in the chat. I hope everyone is comfortable with the concept of machine learning and deep learning. I'll just check in the chat. Yeah, so you all have a basic idea that what is why machine learning is used, then why we came to deep learning, what is the use of going into neural networks, and basically classification when we talk about this sort of machine learning. Just I'm sorry, just give me a minute. Right. So, when we talk about classification, it is a supervised form of learning in which we have a data set where we have labels, and based on those labels, we are actually training our classifiers in order to predict which category the particular data belongs to. Now, that data point, it can be text based or it can be images. Now, when I talk about images, it means, for a simple example, if you can see two objects in the image, so I want to classify, say, whether this particular image is a cat or a dog, or whether the object placed here is a bicycle or a motorbike, or whether a car is placed or a truck is placed. So that is all basically categorizing into categorizing a particular thing into some particular category. So that is classification. Now, object detection means that in a given scenario, whether it is an image or a video, so say if we come to real time surveillance applications or image detection applications, we need something which can track that, okay, this is the particular object which I can see in this image. And that means that basically you will be classifying, you will be categorizing everything into hundreds, based on hundreds of classes, or maybe even more than that. Why? Because we want a real time detection of what all objects are actually present in that particular image. So there is a thin line between object detection and classification, and YOLO basically does everything in one shot. So the difference will be clear in the coming slides. Object detection means that you are localizing the image and you are identifying whether there is one object or multiple object in the images. And the main concept lies behind this, how you are labeling and how you are annotating, that is with the help of bounding boxes. So when we are using bounding boxes, we are trying to localize the presence of particular objects in the image. Now that will be required before you go ahead with the training part. And once your model has been trained, then it will learn to predict whether this particular object which is present in the image, what is that, whether that object is there or not, and what is the class of that, what is the category of that particular object. Now YOLO is you only look once. That is the short form of YOLO. And it is, again, the evolution comes from convolutional neural networks, which are deep learning models based on neural networks, which are used to basically classify images. And what YOLO does is, its role is to divide images into such grids based on the annotations that we have given. So within each grid or cell, it is going to predict bounding boxes for a given object. And based on those bounding objects, you are going to categorize that whether this object is a cat or a dog or a bicycle or a truck or what. So bounding boxes will be predicted, probabilities of the class will be predicted, and basically this object detection come classification task will become extremely fast as compared to the normal classification that we do. So YOLO will make it very fast. Now before
Ma'am,
YOLO came up,
excuse
sorry.
me. Ma'am, you make it full screen.
Yes, sure. I'll do that. I'll make it full screen. So before YOLO came up, we had R-CNN. Now, basically, I hope everybody knows what a CNN is. So CNN basically comes on the, it works on the concept of convolution. And what it does is that for each image matrix, you have a filter, and that filter matrix is going to get convolved with the image matrix. And whatever the result comes out to be, so basically some features are getting extracted from the image. That feature extraction can be done in multiple layers. Basically, you will have convolutional layers, max pooling layer, followed by a fully connected layer, and then there will be an output which will help you to decide, that will give you a probability whether this object is a cat or a dog or any other image that you are trying to classify. Now, RCNN is a region-based convolutional neural network. Now, that means that you are trying to make more intricate CNN networks, which will give a very classic approach to this problem of object detection. Now, RCNN, region-based CNN, also came in different forms like mask CNN, fast R-CNN. But what was its main objective? So it wanted to figure out what are the objects present in this in your images by dividing it into regions. Okay, so CNN is already very much popular for image classification, but for object detection, where there are so many classes and you want a real-time solution, so CNNs were not very sufficient. So when our CNN entered a scene, it helped in fast object detection capabilities, and it helped to capture whatever objects are there within your particular image. So what does the region-based CNN does? It starts by dividing your image into multiple portions. So as you can see, just like as I talked in YOLO, so obviously there also the image is getting divided into grids. There are bounding boxes which identify what particular object is there in a particular grid cell. So RCNN also divides your input image into multiple regions. Now these are called region proposals. Now that how those regions are selected, there are many methods for that. Those regions can be selected using various methods like selective search or use of edge boxes. So that will help to define that what are the regions where likely objects will be there. And these regions, there might be like all the potential regions which are figured out. There are 1,000+ regions. Based on that, the potential regions, this network goes on. Now, say for example, if we go for selective search, so it will split the image segments based on features like color or texture or shape, and then various regions will be built around it, right? And then it will create a diverse set of region proposals. Now, once the proposals are given, that is, I said around 1,000 plus, so 2,000 regions around, they are extracted and they are made to a consistent input size with respect to the CNN. Now that depends what is your pixel size, what are the pixel size of the image, right? So based on that, you are coming to a pipeline which is similar to the CNN. So before now warping again, you are modifying, changing, pre-processing the image, you're expanding the regions where you are trying to predict the objects. And from say from 224 into 224 pixels, you're trying that from that image, you are trying to extract certain features related to the object which is there in the image. So you can see the pipeline here. So there was an image using the selective search. Regions were found out where you wanted to find the objects. And then after extraction of around 2K regions, so again the warped version of it was obtained. And then the features were computed based on the normal method of the CNN, like convolution layer and then max pooling layer and then fully connected layer. And then this was followed by classification. So the final layer, say if it is a softmax layer, they would be able to classify, say whether it is a person or an animal or an aeroplane or a vehicle or so on. So this is how it is basically operating. And the CNN, which was generally used in this part, that is generally a pre-trained model such as AlexNet. So there is VGGNet and there is Inception, and there is AlexNet is there one of the popular pre-trained models which are commonly used. So here in R-CNN, AlexNet was predominantly used in order to perform the classification. Now the weights, AlexNet has been trained on the ImageNet dataset, and that is used for feature extraction and representation. Finally, the final layer of this will be able to classify based on the probability whether it is uh, an animal or a vehicle or a person. So all the features, whether it was color or texture or shape, based on the regions that were segmented from the image, they were extracted, and then further warping was done, and then using the CNN pipeline, we were able to predict the probability of the particular object in the image. So that is how R-CNN was used for detection of the object. Now, output of the CNN, this after when AlexNet was used, so a high dimensional feature vector was obtained. And of course, we have the probabilities because that will decide that what class that particular object belongs to. Now, this is, as I said, the pipeline region proposal generation. First of all, the regions were obtained using methods like selective search. In the region of interest, there are many objects. This was followed by feature extraction. So where each region proposal was subjected to features were extracted with the help of a pre-trained model such as AlexNet. And then the fixed length vector which was obtained, that was further used given to a fully connected layer, all which help you to classify the particular object. Now, extracted features and the classifier that you are using. So, say if you're using a softmax classifier, or maybe you can combine CNN with an SVM. So that depends what kind of classifier you are using. That is going to classify each region proposal into different object classes. Now, further, there is, in addition to this normal classification, there is also a bounding box regressor because we also want to know the location of the object, right? So this bounding box regressor, it will be also able to predict where this object is present in your image. So obviously, when we are detecting the object, one very important thing is that we want to know the location that where that object is placed in the scene. So there it is important that we can get these coordinates with the help of R-CNN. So another thing which CNN could not actually do very well, but R-CNN was able to capture the intricacy. So it was a two-stage process. So basically R-CNN was a two-stage process, right? Now here, first of all, you are doing the region segmentation, right? And then you are classifying it. Second point is that you need to use some particular region segmenting algorithm like selective search or edge box method. So there are many methods which you can opt for. You will have to use that kind of method to generate the region of interest. Third point is that each region that is processed, it is a slow process, right? It is computationally expensive, it is slow because you are doing it in a number of stages. Basically, you are segmenting the regions and then you are going ahead with the feature extraction and then classifying it. So this is not only time consuming, this is computationally intensive also. And second thing is that in situations where we want a very much real time solution, say video surveillance or traffic monitoring, so RCNN may not be the best solution to go for because it might have a delay in detecting what object was there in the scenario. So some applications like these, they need a very quick identification of multiple objects, and you need fast results. So for critical applications, it is not appropriate that we went for a choice such as RCM. So these basically were the limitations, and even when its variants came up, like masked RCNN, so again it was basically segmenting the image based on pixels, and then it was working on feature extraction. So all of these had a few limitations. The inference, the deduction of results was low because of the time taken, and for real-time tasks, it was not very practical to use RCNN because even the memory, the need to store these region proposals, as I said, 2K proposals, region proposals were generated. It was memory intensiveness was too much, right? And even when you are, say, using CNN, AlexNet followed by SVM, you're using a complete CNN pipeline along with a classifier. So, and then followed by a bounding box regressor because you need to find the location. So, the complexity of these parameters was also very high. So these were the limitations why RCNN was used, but then it paved way for an architecture such as YOLO for object detection. So as I said, finally YOLO came up, and when I talk about YOLO, again the key idea is to detect the object and detect the coordinates, but it does everything in a single shot problem. Okay, so like earlier methods, it is going to predict the bounding boxes and the object categories, but it will not be doing it in different stages just like an RCNN. It is going to do everything in a single shot. It's going to predict your bounding boxes, it is going to tell you which category of object it is going to do everything for you in less time with less training complexity and less memory intensive. So this is the new generation model for your object detection, and when we will see it practically, things will make more sense, and you will understand that why it is a very much preferable model to go for your tasks related to object detection. So yes, so as you can see, whatever object is there in your grid, so if this is a 448 cross 448 image, so it is divided into 64 cross 64 cells. It is divided into 7 grids, and each cell basically is 64 cross 64. So whenever you take the image, you resize based on your requirements, and you divide the image into grids. Now the concept behind YOLO, each cell will be responsible for predicting one object, whatever object is there within it. So it is responsible for predicting whatever object is there with respect to relative to the center of the cell. So each cell, when I'm talking about, as you can see here, so it is this 64 cross 64 cell that comes to me because this 448 cross 448 image gets divided into 7 grids. And if it gets divided into 7 grids, then it means that each cell is 64 cross 64. So each cell's center with respect to that will be responsible for predicting what object is present in this. So say an example, I consider an image. Now, when we talk about bounding boxes, there are going to be 4 things. One is the x coordinate, one is the y coordinate, one is the width, and one is the height. Okay. So how do we calculate this? Now see, if this is a 448 cross 448 image, Now I come to the bounding box where you can see that the width is 142. So this width divided by 448 is the change in W. So this delta W means what is the change in the width. What is the width with respect to the total image? Because we are talking about this particular bounding box. Similarly, the height with respect to the total image, so say if it is 250 divided by 448, so you can see that we get the last two coordinates. Now coming to this x and y coordinates, right? So this 200, say if it is the point of the bounding box with respect to the center. Now with respect to the center, if the coordinates of the center are 192, 256, so this change in x is calculated as 200, which is the bounding box coordinate, minus the center of the cell. Because I told you that YOLO, whatever object is there in the bounding box, it is calculated relative to the center of the cell that you are making the bounding box with respect to. So if this center is 192, 256, so this change in x coordinate is 200 minus 192 divided by the cell size 64, that gives you 0.13. And for y, similarly, if the bounding box y coordinate was 311, so what is this delta y? This is 311 minus the center coordinate 256 divided by 64, which is the grid cell, which is the size of the each cell in the grid. So that is approximately 0.87. So this is how it is going to calculate the location of the bounding or the bounding box coordinates with respect to the center of the grid cell, whatever the center of the grid cell is coming out to be. So this is one important thing, that how it is calculating the relative position, and that is why grids are very important, because with respect to the cell's center, it is going to calculate the locations of the bounding box. So first thing is this label encoding. When I talk about label encoding, for every grid you create labels, targets like this. If there are no objects, then it means it is all, this label encoding is all zero. The object, if the object is there, then the location of the bounding box is relative to the grid cell. And for classes, we are going ahead with one hot encoding. Now, if you see X, Y, W, H, now these are the four things that we have already discussed, how it comes out to be. And if we talk about C, now C is class probability. That means that say there are 20 classes, right? And whatever position there is a class, there is a probability that there is an object, we will put one there. So say if there is a vector of 20 values, so you put one in that position where class, where there is an object, where there is the probability that a particular class of the object will get predicted. Okay, so if object is there, means obviously it is a 1. If object is not there, then it is a 0. And I will also show you that how this entire vector of 20 values will look like when we come to the next example. So how this total prediction vector is obtained? Now each grid cell, how YOLO works is the basic behind it. Now each grid cell is going to predict two bounding boxes. Okay, so one bounding box BB1 and other bounding box BB2. Okay, so now for each bounding box, we have a delta x that we calculated with respect to the center of the cell. We have a delta y, we have a delta w, we have a delta h, and we have a class probability. Now, this class probability, it will be a feature vector of 20 values. So why? Because say if class 1, yes, this object of class 1 is present here. तो वहां पे हमने 1 कर दिया, बाकी सब 0 कर दिया. ठीक है. Similarly, if object class 20 is 19 is present there, so 1 और 19 में 1 हो गया और बाकी सब में 0 हो गया. तो ये एक 20 वैल्यूज का फीचर वेक्टर है. एक बाउंडिंग बॉक्स वेक्टर है which is having these 5 values x, y, w, h, c, और एक बाउंडिंग बॉक्स 2 है which is again having these 5 values x, y, w, h, c. So 5, 5 and 20, that gives me 30. तो ये जो आपका टोटल फीचर वेक्टर बना, that becomes 7 cross 7, that is because of the grids. आपके जितने नंबर ऑफ ग्रिड्स थे, ठीक है, 7 cross 7 cross 30. So 30 is because of these vector values जो टोटल हमारे पास आ रही. एंड फाइनली होगा क्या? नाउ द ऑफसेट्स जो है लेफ्ट कॉर्नर, राइट कॉर्नर, बेस्ड ऑन एवरीथिंग, बेस्ड ऑन द कोऑर्डिनेट्स, हमें बाउंडिंग बॉक्स के भी जो वैल्यूज है वो मिल जाएंगी. Now prediction vector जो है वो आपको class probabilities, why the class probabilities will be given, because we want to know that what category or what class of the object is present in that particular grid cell. Now when the bounding box that gets based on this whatever prediction vector we are getting, we will retain the values where confidence score is the highest. Now again I'll come to how this confidence score is calculated. So we have to see which bounding box vector has the highest confidence score. We will keep that, and thereon we will be predicting that, okay, say a vehicle is present here or a horse is present here, and so on. Okay, so before I come to YOLO, the loss function and this confidence score that is calculated. So this is the very basic of YOLO, but the most basic architecture which was proposed, that was YOLO V1, and it was highly inspired by Google NIT. So Google NIT is a very simple pre-trained model which consisted of some convolution layers and max pooling layers and fully connected layers. So it had initially, YOLO V1 had initially 24 convolutional layers, and then it was flattened into a vector followed by two fully connected layers. So initially, YOLO V1 was trained on the ImageNet dataset, okay, and then there was fine tuning was done using the Pascal dataset, which got the images of this size 448 into 448, as I showed it to you. Agar R-CNN use karte, again you would have to warp it, and then you would have to use AlexNet, and then you would have to predict something. Lekin YOLO ke case mein, you are dividing it into grids. When you are labeling, of course, you are giving the bounding boxes, you are using annotations for the bounding boxes, and then YOLO is doing its work and it is predicting your entire prediction vector, which has bounding box 1, bounding box 2, and the class probabilities. Whichever bounding box will have the higher confidence, that will be kept, and it will be predicted that this particular class is the object which is present in your image. Okay, so yeah, so initial image, flattened, going through the network, then reshaped, finally the prediction vector that you got, 7 cross 7 cross 30, and 30 I have explained why, because the prediction vector here in our example was of size 30. Now the loss, now obviously even in all deep learning networks, we are calculating loss in some method. So that loss is basically predicting the difference between the actual and the predicted values, right? And here, if we talk about loss with calculation for YOLO, so definitely we have to understand that whether it is, what is the class probability, what is the confidence value, there is a loss function for bounding box as well. So when you're talking about a normal neural network or a CNN, generally you calculate a loss where you find out the mean absolute error or the mean squared error, right? Or the root mean squared error. So आप loss इस तरह से निकालते, you can go for binary cross entropy. There are many loss functions जो बेसिकली बताते हैं कि आपके जो प्रिडिक्टेड वैल्यू और जो एक्चुअल वैल्यू उसमें डिफरेंस कितना है, एंड दैट इज व्हाट यू वांट टू मिनिमाइज बाय यूजिंग सम ऑप्टिमाइजेशन एल्गोरिथम. Here in YOLO, you have to find the loss, which will be the sum of bounding box loss, confidence values, and the class probability, the loss because of that. So ideally, if I talk about the bounding box loss, that means if an object is there, we can keep a 1 and multiply with it. And if an object is not there, again 1 into the loss when object is not present. But we are trying to add a penalty term and reduce the value that comes कि अगर object नहीं है, so we can lower down that part of the value and we can give priority to the values which come if there is an object in the grid. The total loss that will be found is this what value we are treating, जो हम coefficient रख रहे हैं, into the bounding box loss plus the confidence value plus the class loss due to the class probability. Now how do you calculate that? See, now let it be in a clear manner if I talk. तो बाउंडिंग बॉक्स लॉस को आप इस तरह से कैलकुलेट कर सकते हो. यू हैव द कोऑर्डिनेट्स फॉर द चेंज इन एक्स, डेल्टा वाई, डेल्टा डब्ल्यू, डेल्टा एच. So this is actually trying to, so where you can see these x hats, So that is the ground truth जो आपने labeling करते time bounding box दिया है. And this star 1, it is the coordinates of the predicted values for delta x, क्योंकि बाउंडिंग बॉक्स प्रिडिक्ट होगा, आपके प्रिडिक्शन वेक्टर में बाउंडिंग बॉक्स 1, 2 एंड क्लास प्रोबेबिलिटीज भी है, तो उनके बीच में जो डिफरेंस है उसका स्क्वायर्ड एंड द सम ऑफ ऑल दीज कोऑर्डिनेट्स दैट विल गिव यू द बाउंडिंग बॉक्स लॉस. एंड इफ आई टॉक अबाउट द कॉन्फिडेंस, that is the squared error between the predicted confidence and the encoded label confidence. Simply अगर object है then confidence value is 1, and now whatever is predicted that is subtracted from 1 and the square is taken. Agar object nahi hai then it is 0. And the class probability, so like obviously if you find the sum of squared errors over all the class probabilities, so those are जो आपकी 20 वाला जो prediction vector था, so there will be some probability associated with each class. So say अगर class 1 है, say 1 is there या 0.5 is there, so if you do the sum of squared errors over all the probabilities for these 20 classes, so that is how your classification loss is calculated. So ultimately जो final loss है, that will be calculated on the basis of all these losses and values that you have calculated. Also, now this is the loss, right? And YOLO mein there is something which is called IOU, intersection over union, and mean average precision. So these are used to estimate how it is performing with respect to the object detection. So IOU means, now you understood that you got a predicted bounding box, you have a ground truth bounding box. So IOU is basically what is the area of overlap divided by between the two bounding boxes. So one is the ground truth जो आपका label था, and one is the predicted जो आपका जिसका higher confidence है, we are keeping that bounding box, and accordingly उसके coordinates भी वहां से you get. Right, so the overlapping between the ground truth and the predicted box divided by the union of both the boxes. So that is what is known as the intersection over union. Now, based on this, you get a mean average precision value. Now, this is a very important performance metric, जिसके basis पर आपको पता चलता है whether the object detection is successful or not. Because what it is doing is, so there can be different thresholds of IOU. Whatever you set, based on that, this MAP value will consider both precision and recall, then calculate the average precision for each class, then calculate the mean of all the average precisions, and then it will give you a value. So normally when you are doing some classification, जब आप neural network या CNN use करते हो, so you are going for precision, recall, and F1 score. So here we are going for mean average precision in order to evaluate that your performance of object detection is good or not. So when we do it practically, again you will see that how these values look like. So when I said that YOLO V1 was the most basic architecture, there were certain limitations associated with it. So it predicted only a fixed number of bounding boxes per grid cell. So like I said, the prediction vector में मान लो 2 bounding boxes predict हुए. And it was able to detect objects, but localization was again poor in the sense it could not accurately identify कि जो आपके objects हैं, they are big or small. So based on different object sizes, it was not able to handle these very well. कई बार picture में image में noise हो सकता है या कुछ आपकी details miss out हो सकती हैं. So this was something which made it a little less precise. So even when we talk about small objects, there was a little difficulty in handling the scenario. Even there were other models, right? So just like R-CNN, there is another model, SSD. And that SSD, it proved to be better. So this is again a single shot detector SSD. It is similar to YOLO, but what it does is that it has a backbone and it has a head, and it also works in a manner that it is finding the probability of the object, the width, height, the horizontal, and the vertical coordinates, right? So it takes window sizes and the aspect ratios to solve the problem. So we're not going into SSD right now. It is also not as popular as YOLO, but yes, when I talk about comparing, then SSD proved to be better as compared to YOLO V1. So there was the limitation that can we have a model which is better than YOLO V1 as well? So there came up the next version of YOLO, which was YOLO V2. So YOLO V2 में क्या हुआ कि as you can see that image के ऊपर काफी सारे epochs चल रहे हैं, right? and that has also increased. जो backbone, now backbone is your CNN ka architecture basically. So there is, just like there is AlexNet, VGGNet, so YOLO V2 incorporated the darknet architecture of CNN, and that was the main backbone. So backbone is always the CNN layers that you are using in order to perform the object detection. Then the training was done for a few epochs, और उसके बाद 10 अलग से epochs रखे गए थे for fine tuning and for custom object detection. So this process showed that YOLO V2 was able to perform better as compared to YOLO V1, and even the MAP value was improved by 4%. So this, in the next version of V2, this thing was taken care of, that how we can prove to be better in terms of performance as compared to your SSD and R-CNN models, and even YOLO V1. So again, as you can see that there were various convolutional layers, right, that were used here itself. There was a certain improvement in the architecture, so a pass layer was used, because YOLO V1 had the problem of resolution also. It was not able to capture very fine details as compared to when large object sizes were there or small object sizes were there. So when there was a pass layer, so this helped to localize a little better, and the resolution issues were improved, right? So this helped to actually improve the object detection performance in terms of the MAP. Now, all these improvements which are there, I would suggest that you can go ahead and look for research papers that how each YOLO model, like if you want to go into detail and find out some research problem, you can compare which layers have been exactly added to make one model better than the other, so that you can decide further that what will work the best for you. Now, when it came to YOLO V3, so it introduced darknet, another model of CNN, which was darknet 53. So there were 53 layers in the classification framework. So again, it is trying to improve the number of convolutions that are taking place, right? There were skip connections as well. So skip connections, again, if you imagine a ResNet network, for example, it's CNN pre-trained network, it again helps a lot to improve the feature extraction. There was use of activation functions such as ReLU and batch normalization to reduce overfitting. Another important catch here was that there were no fully connected layers. So residual layers, like I said, and we have in ResNet too. So the skip connections which are there, they again help you a lot. So this YOLO V3 proved to be better as compared to YOLO V2, and even the speed was better. So speed is one more thing, because in case of R-CNN, we observed that it was computationally, it was not very good. The amount of time it was taking, it was more, and the accuracy was less. So here accuracy is more and speed is also more. So definitely it is a win-win situation if we are coming to this next version of YOLO. Then came the next version, that was YOLO V4. Now, obviously, there was an improvement in speed here and improvement in accuracy. So basically, if you check out this diagram, so this is how a YOLO network looks like. So you have an input image, you have a backbone, which is basically a CNN framework, like ResNet, VGG, Darknet. Then you have a neck, which is optional, but there can be use of methods such as PAN, SPP. So like there are many different methods, but if I give you an example, PAN is path aggregation. So it aggregates all the features from the top and the bottom layers of your network. So based on your requirement or based on the data, this particular neck can be changed. And then you have the head, which goes for the use of another CNN layer, or maybe you can use an R-CNN here also, or any other. Basically, if you are using YOLO, so that those layers can be that those prediction layers will be the head of your network, right? But you can try and change the head and see that if you can integrate something else into this network also. So this is a basic layer of basic pipeline of YOLO. So when we came to YOLO V4, this was very well implemented. So the backbone was used to extract the features. The head was used to, or the neck, it was used to aggregate features using various methods. There was no concept like this in the older models. And then finally, the head had a normal layers of the YOLO framework in order to predict the bounding boxes and the class that it falls in. So like this, there were a lot of improvements in 5, 6, 7. So I think there is enough fodder for everyone to go ahead and check out that how each model wins over the other. Now the latest ones that are used these days are YOLO V8 and YOLO V9. So why they have gained a lot of popularity? Because of the speed and accuracy, and because the real time detection of objects has been improved a lot. So even when there is uh, in a surveillance problem where there might be less bandwidth or more uh, problematic to detect what objects are there. So YOLO V8 and V9 have been very fast enough to capture the features effectively and classify or detect the objects which are there in the scenario. So YOLO V8, it shows a very good capability of achieving a very high precision and recall in actually detecting the object. So it means that your MAP will also be very high. And YOLO V8 can be customized very easily on your custom datasets, right? You can train your own object classes with respect to YOLO V8 and V9. Similarly, YOLO V9 made use of more techniques and aggregation methods and gradient methods so that more information was captured while extracting the features and for minimizing the loss. And definitely these models, each model that was succeeding the previous model, it became better and lightweight as compared to the one. So the learning capabilities of the model were also increased. The preservation of vital information was also increased. The accuracy and the performance and the time taken, they were also improved. Right? So YOLO V1 is the original, V2, V3 improved the accuracy and the bounding boxes. V4 made use of darknet 53 and improved again the backbone. V5 was again open source implementation working with all sizes of objects. 6 and 7 improved the speed and accuracy. 8 is a recent version, but 9 is the most latest, and I think even 10 has been introduced. So again, it improved the efficiency and flexibility. Now, when you decide to use YOLO, as is in the practical part when we are going towards it, so the applications can be many. Like if you want to do some kind of traffic monitoring for self-driving cars, for obstacle detection, for surveillance systems, for security systems, you want to track individuals, you want to find out suspicious activities. Like one of my students developed an object detection system for detecting suspicious objects on railway platforms, because generally like people when some baggage and all is kept, so people get scared, or somebody made a pothole detection system, right? So these are things that you want to actually detect, and it's not something that you can easily just make a classification task and go ahead. Medical imaging, again, MRI, CT scans, whatever images you're getting out of it, so sometimes you need to detect something within it, or you want to detect the cells, different kinds of cells which are present in the blood. So medical imaging also makes use of YOLO to a great extent. Now, this is something which you can decide what domain you want to go for. Now, I'll just stop here, right? Uh,
Ma'am, there are few questions in chat.
Questions. Yes, yes. So before we go to the practical part,
Yes,
right. So for leaf disease detection, now see, it depends that what kind of data you have. So anybody like who has Vivek, Madhulika. So what if the data you are having regarding the leaves? So is it a particular kind of disease where you can have spots or the color might change or something like that? Okay, okay. Okay. So basically, if you are trying to detect, now you have to channelize it that way, that if you're trying to detect key, there is a leaf which is having certain spots on it, which that it is the cause of a particular disease. So you can try annotating it, and that particular, and obviously when you will be giving your test image to your model, it will be able to detect those spots on the images. And if those spots are there, then it means that obviously your leaf is infected. Now, in other cases where, say, the color might change, right? So, there I would say that going for a classification task would be better, because you have two options. If the leaf is, if this disease is causing the color of the leaf to change or to say wither, right? So that is one category, and a normal leaf is the other category. So it depends, what kind of disease you are trying to predict. If it involves something where you can, clearly detect कि वहाँ पे lesions हैं या वहाँ पे spots हैं, तो वहाँ पे आप उसको annotate करके you can see that if it is trying to detect those lesions or not. So it has to check something in your image, right? And then accordingly it has to categorize. So you can decide कि इसका जो label है उस हिसाब से वो क्या रहेगा कि ये spotted leaf है या नहीं है. अगर color change है कुछ है तो वहां पे मतलब मेरे एक्सपीरियंस में दिस क्लासिफिकेशन सिर्फ क्लासिफिकेशन टास्क जो है आपका दैट कैन वर्क फाइन. सो अगेन इफ यू हैव एनी थिंग लाइक इफ you want to discuss or try out after the session, I will also share my email id so we can get in touch and we can discuss the various aspects of it. Yes, Pradeep, you want to ask something?
Ma'am, first thing I want to collect my own data set. So, what is the procedure? How we can annotate this once I find the images for that?
Yes, that is something that we are going to discuss in the practical part, that how you can do it. And I will tell you a very nice interface and an easy way of annotating and labeling. Right?
Another
So we,
thing, ma'am,
yeah.
how we can calculate the mask for an image? If, for example, if the leaf is infected from some disease, I want to calculate the mask for that for semantic segmentation.
Mask of the image.
Yes, ma'am.
So can you like elaborate a little more that with what respect you are trying to, because there are various methods of calculating the masks as well. So like how do you want to, whether you want to go for a convolution, because that depends, if you are say using a CNN, okay, you are not say using YOLO, you are using a CNN. So you can use some odd kind of filter matrix, which we can call a mask matrix or a kernel which is having odd number of which is having odd dimensions with all ones say. So that will act as your mask filter. Yeah, फिर you can go for certain morphological operations like erosion, dilation. So these are certain image processing techniques that you can use separately, on your image. Classification से पहले you can go for the convolution process, or you can go for
No,
the
ma'am, where I have tried so many things that क्लाहे मैंने ट्राई किया था, हिस्टोग्राम इक्विलाइजेशन मैंने ट्राई किया, बट स्टिल दे आर नॉट वर्किंग. मुझे क्या करना, सेमेंटिक सेगमेंटेशन करना, उसके लिए मुझे मास कैलकुलेट करना है. सो अगर मेरे
वो
पास फ्रेश इमेजेस
semantic.
हैं, अगर
हाँ,
डेटा सेट में मेरे पास अगर मास्क नहीं दिया हुआ है, तो मैं कैसे मास्क को कैलकुलेट करूंगा?
वही मैं आपसे पूछ रही थी कि आपका जो मास्क है आपको किस पर्सपेक्टिव में विद रिस्पेक्ट टू योर डेटा आप क्या कैसे क्या 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 कैलकुलेट करना क्या चाहते हो, हाउ डू यू वांट टू
मैम
यूज इट
जैसे
फर्दर?
फॉर एग्जांपल मैं मुझे मैम एक्चुअली जो डिजीज पार्ट है लीफ का, वो मुझे मतलब सेग्रीगेट करना, मतलब बिल्कुल जो है ओनली दैट इन्फेक्टेड पार्ट आई कैन सेग्रीगेट फ्रॉम द रेस्ट ऑफ द लीफ.
तो यू वांट टू सेगमेंट इट बेसिकली.
यस मैम.
तो सेगमेंटेशन करने के लिए हैव यू ट्राइड एनी काइंड ऑफ जो आपने टेक्निक्स ट्राई की है वो बेसिकली उसमें आपने क्या अभी तक क्या किया, आपने क्लाहे वगैरह यूज किया तो आप उससे क्या एक्सट्रैक्ट कर पाए?
मैम क्लाहे जस्ट सिंपल क्लाहे है, या फिर हिस्टोग्राम इक्विलाइजेशन मैंने ट्राई किया, उससे फिर मैंने क्या क्या CNN लगा के मतलब फीचर एक्सट्रैक्ट तो किए CSV में, बट द एक्यूरेसी वाज नॉट मच एज आई वांटेड.
क्योंकि द टेक्निक्स दे कैन बी मेनी टेक्निक्स. आप बेसिकली अपने अगर इमेज के ऊपर मॉर्फोलॉजिकल ऑपरेशंस भी लगा लो या फिर बाउंड्रीज की हेल्प से सेगमेंटेशन कर दो और फिर पिक्सेल्स को एनालाइज करके you can assign a particular category to it, for example. That is one thing, right? And you have tried certain techniques on it. But if you say the accuracy is not much, so maybe you are using a deep learning network to classify further, are you?
Yes, ma'am. I tried both shallow machine learning as well as deep learning technique.
So what I suggest is कि आप एक बार अपने जो न्यूरल नेटवर्क के हाइपर पैरामीटर्स भी हैं उनको भी थोड़ा सा ट्यून करके देखिए कि अगर आप लेयर्स और के ऊपर या ऑप्टिमाइजर्स के ऊपर या लॉस फंक्शंस के ऊपर कुछ काम कर सकते हैं जिससे कि आपकी एक्यूरेसी जो है या इपॉक्स कितनी देर के लिए आप ट्रेन कर रहे हैं, सो इफ यू कैन इम्प्रूव ओवर दैट ऑल्सो। हैव
मैम
यू
एसवीएम में तो मैंने ट्राई किया था, ग्रिड सर्च सीवी जो कर मेथड था, उससे मैंने ऑप्टिमाइज पैरामीटर निकाले, बट स्टिल
ऑप्टिमाइज कर दिए, राइट?
उससे मैम नहीं हुआ है,
And
मतलब
your
उतना।
data is image based, right? That is why you are trying to segment and
यस मैम। तो मेरा
so
पहले
the
मैं
हाँ,
सिमेंटिक सेगमेंटेशन करने के बाद आई वांट टू एक्सट्रैक्ट द फीचर्स सो कैन आई कैन अवॉइड द रेस्ट ऑफ द इमेज। सो वो ओनली मुझे इन्फेक्टेड पार्ट के अगर चाहिए तो उसके लिए मुझे सेगमेंटेशन करना है।
ठीक है, आपने सेगमेंटेशन कर ली, उसके जो भी टेक्निक्स आपने यूज किए या आपने बाउंड्रीज
मैम
उसकी आपने मान लो कर ली,
दैट
ठीक है, जिसमें आपके पास इन्फेक्टेड पार्ट आ गया, राइट?
यस मैम।
उसके बाद अब आपका काम ये, अब इससे जो फीचर्स एक्सट्रैक्ट, अब उसके बाद ऑब्वियसली एक काम होगा लेबलिंग वाला। तो सपोज आप क्लासिफिकेशन कर रहे हो, आपने
दैट इज
लेबलिंग करी कि दिस इज इन्फेक्टेड, दिस इज नॉट इन्फेक्टेड, करेक्ट?
यस मैम।
तो आपकी एक तरह से जो सेगमेंटेशन वाला काम है वो यहाँ पे खत्म हो गया, करेक्ट?
जी
अब आपको करनी है क्लासिफिकेशन। तो आप एक मतलब यू हैव ट्राइड CNN, हैव यू ट्राइड?
यस मैम, सीएनएन में ट्राई किया। एक्चुअली
ओके,
मैं
तो
ट्रांसनेट 201 ट्राई किया था, ठीक है।
ओके,
सो
तो व्हाट, हाँ, व्हाट वाज द एक्यूरेसी दैट यू गॉट?
accuracy I got from that, ma'am, but I want to use different approaches. I want to use this semantic segmentation. After that I want to extract the deep learning feature, then I want to apply SVM.
वही मैं आपको बोल रही हूँ ना, सिमेंटिक सेगमेंटेशन तो आपकी क्लासिफिकेशन टास्क से पहले ही हो गई, जिसमें
Yes
कि
ma'am, but
आप
वही है, वही semantic segmentation ये नहीं हुआ है, that's why I want to find out that how I can approach that.
डेफिनेटली, एंड वो जो सिमेंटिक सेगमेंटेशन जिसकी आप बात कर रहे हो ना, दैट इज बेसिकली जो आप अपनी मान लो इमेज की मास्किंग कर रहे हो सपोज, ठीक है, और उस बेसिस पर
जी
आप हर पिक्सल को एनालाइज करके ये बता रहे हो। इवन अगर मैं कहूँ कि मैं एनोटेशन भी अगर बोलूँ ना, ठीक है, तो वो आपकी काइंड ऑफ सिमिलर टू सिमेंटिक सेगमेंटेशन है, क्योंकि वो लोकलाइज कर रही है किसी चीज को। अब वो जो आपने लोकलाइजेशन करनी है वो करने के लिए आप जो n नंबर ऑफ टेक्निक्स हैं जो आपने जिनमें से यूज किया भी है, यू आर ऑलरेडी डूइंग इट, दैट इज व्हाट आई एम ट्राइंग टू से कि आप सिमेंटिक सेगमेंटेशन क्या है, आप बेसिकली बिफोर द प्रोसेस ऑफ फीचर एक्सट्रैक्शन एंड क्लासिफिकेशन यू वांट टू फिगर आउट कि आपके जो ऑब्जेक्ट्स हैं उसमें आपका जो वो एरिया है, डिफरेंट पार्ट्स ऑफ द इमेज है, उसको आप मास्क करें एक तरह से, या आप उसको सेपरेट कर रहे हैं रेस्ट ऑफ दी उससे, एंड बेस्ड ऑन दैट आप लेबलिंग कर रहे हैं। सो आई थिंक यू एज यू आर सेइंग, आई कैन फील दैट यू आर ऑलरेडी डूइंग इट। तो आप इसके अलावा और क्या करना चाहते हैं मतलब अपने टास्क में?
मैम मेरा क्वेश्चन, now I'm changing the
Ma'am,
question.
ma'am, time is limited, so we will
Okay,
take this question later on.
okay sir,
Uh,
okay, no problem.
and there are so many
Definitely, like we,
sessions afterward also for the segmentation.
Okay sir, okay, no
Oh,
issues.
oh,
Okay.
okay. So definitely we can, I will share my email ID also at the end of this and we can discuss upon it, because definitely I think ki a little bit of hyperparameter tuning and all can help you to improve your accuracy as well, right?
Okay
So
ma'am.
let's discuss on this after the session. Yes, I will share my email ID.
Okay.
Hmm. Even if I can see your data once, then I can give you more suggestions, right? वो obviously data देख के थोड़ा clear हो जाता है कि यहाँ पे आप क्या क्या और कर सकते हो, correct? So we have more questions. It won't be recommended to use two-stage detectors instead of YOLO for detection of tumors. See again, टू स्टेज डिटेक्टर्स की अगर एपी आपके पास ज्यादा भी आ रही है तो भी, एज आई सेड, इट इज वेरी टाइम कंज्यूमिंग एंड इट इज वेरी मेमोरी इंटेंसिव, and even for medical imaging sometimes we require a lot of, there should not be a trade off with the time with respect to the performance. So that is why YOLO is something which came up to avoid these challenges जो कि टू स्टेज डिटेक्टर्स के साथ आ रहे थे। And real time object detection के लिए दोनों YOLO V8 and V9 can be used. So you can use both. इनके versions जैसे जैसे upgrade हो रहे हैं, you can compare the performances of different architectures with each other. Even if you go for some good research papers, so people have tried to compare many different architectures with each other. So you'll get a very good idea कि आपके पास जो कौन सा ऐसा आर्किटेक्चर है जो कि किस सिचुएशन में अच्छा परफॉर्म करता है. So, right, so there is keeping the time in mind. Now let us go towards the practical part of this, right? And for that, I think some this will be shared with you, collab notebook. If you have it, you can definitely open it side by side. You can try out things, but there are certain things जो आप अभी सब कुछ नहीं कर पाओगे because it will take time. And as somebody asked कि annotation कैसे करनी है, क्या करना है, I have to tell you everything. So I'll suggest that let me show you things, how it is going on, how the entire process is going on, and उसके बाद do try it at your end. And I've already shared my email ID, so whatever queries and whatever ideas, or if you need to discuss about your data with me or about this process of object detection, so you can get in touch with me and I'll love to discuss it with you. So there is this सबसे पहले जो pip install ultralytics, ये हमने क्यों किया? Now I hope everyone is familiar with Google Colab. It is a platform where you are doing you're implementing your deep learning algorithms. It is basically a platform for coding, right? आप यहाँ पे कोडिंग कर रहे हो तो जो आप अपना डीप लर्निंग मॉडल बनाओगे या कुछ है, इट इज नॉट दैट यू कैन यूज ओनली गूगल कोलैब इफ यू हैव एनाकोंडा इंस्टॉल्ड ऑन योर सिस्टम or there is any other platform that is well and good. Why I like to use Google Colab? Because it is very handy. I can always connect my Google Drive and access the data set, or I can always download data set from a particular repository to Google Colab. So it will be really easy and less complicated to use this platform. And if you have some other platforms installed, that is again, you can go ahead and use. So if you are using Google Colab, so you can just type collab.research.google.com. यहाँ पे code और text के लिए आपको code cells add करने के लिए you have got some options,
They
right?
have taken all these sessions, ma'am. They are working on Google Colab.
Okay, fine. So I can directly come to how
Yes, ma'am.
we can go for object detection. Fine.
Yes, ma'am.
So there is this website called RoboFlow. ठीक है? So Ultralytics ने YOLO के versions update करके they are making all the packages of this YOLO architectures, YOLO frameworks. So that is why the first step that I have done is installing Ultralytics, right? And pip install, basically in Python, it helps you to install your particular libraries. So this Ultralytics will help me to import. Now, when I do pip install Ultralytics, so this gets installed here in my Google Collaboratory, and the path, now many will get confused, but let me just make it simple. This Ultralytics installs all your packages in this path, which is given there. So if I just check this user, okay, then we have local, then we have lib, then we have Python 3.10, then we have DST packages, then we will find out where is Ultralytics. Okay, so in Ultralytics, you have got all these things which are related to YOLO. So see these models, everything is there. YOLO World is one of the other models. There are other even packages which you can explore, how the different things are getting downloaded here. So see these packages V10, V3, V5, V6, all these are getting installed here in your path because Ultralytics has it in this entire repository of YOLO. Okay, so basically वो सब pip install करके आपके पास आ गया. And from Ultralytics we can import YOLO. Now I've written here pip install RoboFlow. Now what is RoboFlow? See, if you go to roboflow.com, it will ask you to sign in and make an account. And so one of you also asked me, how can we annotate our objects? So I find this platform really useful to annotate. Now let me just show you. So actually, what I'll be doing here, I have another RoboFlow project, which one of my students worked on recently for underwater object detection. So I'll be doing that on Google Colab. And in this RoboFlow, I'm going to give you an idea that how to upload images, how to annotate, how to run YOLO. Even you can run YOLO on this RoboFlow platform also, but it is not open source that way. It only gives you 2-3 credits to actually train your model. So if you can see here, so once you will sign in and you will create a new project, so you will get options for uploading your data, for annotating. So like this particular data set, if you see, there was this is a random data set where there was traffic data and objects data. So this was first of all, first this you have to upload the data set that you want to annotate. So the object, the data that you annotate, initially it will be unannotated, right? So when I want to annotate, right, when I have to annotate, so at that time I'm creating bounding boxes around that object. And at that time, I'm giving the class names also, like auto, bike, bus, car, because I want to detect the various objects which are present. Now, if I select, I have this traffic. We'll have to see if I have that data set with me or not. Anyways, now if I select the files here, or if I select the folder, it's going to give you all your images here from that particular folder, right? And if you will get an option here that how many images are annotated and how many are unannotated. Now this you can see is the example of an annotation. So basically when you will be annotating, you will create a bounding box, okay? And this bounding box will obviously track what is the location of the bounding box, what are the coordinates, and what is this object. So this object is basically a cow. So you will save it, you will move to the next object. So again, you can annotate, and if you think that it is a very tedious task, of manually annotating everything, then RoboFlow also has this automated annotating tool which assists you in, annotating similar objects together. So that is one of the good things that has been really going to make annotation easy for you. Now, when you annotate, it looks like this. So those who were wanting to create their own data set and annotate it, I will recommend you that you can use this platform and annotate with all the different classes that you want. There are many other annotating platforms also, but why my personal choice is RoboFlow? Because it has a very streamlined, flow of things, and I can very easily connect it with my Google Collaboratory also, and I can keep doing my object detection tasks as much as I want. Now, when I have to, now when I am done with the annotation part, obviously, as many objects that I give, so they are also tracking the bounding box with respect to the objects, and it is also giving you the classes that this is the particular category of the object which is falling in this bounding box. Now, this analytics is just to analyze what all images are there in your data set and all. We are more concerned with the generate part more. Now, when you come to generate, so it will show you how many images are there, how many are annotated, how many are unannotated. So say I have 19 classes here, and then I have an option to divide it into training and testing. So you all have been familiar with machine learning and deep learning, where training and validation and testing must have been discussed. So generally, like if we divide it into 70s to 20s, so that means 70% of your data will be used for training, 20% will be for validation, and 10% will be for testing on unseen data. Now, in the third process, when we are coming to pre-processing, so you can resize your image, you can change the orientation, you can augment. Now, what is augmentation? Augmentation means that I can try and use different kind of operations like cropping, rotation, increasing the brightness, saturation, and things, so that I can increase the amount of training data. Because the more the training data, the better will be the training and the better will be the results. So, of course, the images are less, but and the MAP is also for this particular case, they have not got a very good performance there. So then I'll show you how we have figured out the underwater object detection process to make it very simple. And last will be true with it. So then you can just do continue and you can decide which version do you want to use. So this uh, training was based on the COCO model. Now COCO is a common objects database on the basis of which many common objects and all have been trained for YOLO. And plus you have given your classes which the model is going to predict for you. And now when it will be running YOLO on this, right? So the performances will be clear that what is the performance of the model with respect to the mean average precision. And there was somewhere I can see the model evaluation as well. Yeah, so the MAP is not very good here because I've not really spent a lot of time on this data set and proper fine tuning and everything, the proper annotation and all. There were very limited number of samples actually. So obviously everything is going to affect your performance. So the MAP is pretty less here. Okay, but sorry, anything? Anybody wants to say anything? Okay. So there was some sound, that's why I'm clearing, right? So yeah, so this is one thing that you have to keep in mind, that when you're going ahead with using your free credits, so please properly annotate your objects and make sure that your training data is good in number, and then you use some data augmentation as well. But with free credits, there will be some issue in the amount of images that you can work on and everything. So now, if all of you can see here, when you have understood this flow, so you see a button here, download dataset. Now, which format do you want it to be in? So that will give you all the options, YOLO Darknet or YOLO V7, V8. So there are different kinds of things that you can explore here on RoboFlow. So what I'll do is, say if I select YOLO V8 itself. So there are two options. You can download the zip to your computer. Okay. What it will do is it will download these things on your data on your system. So this all data set and all is getting installed and in my system as well. The second thing that you can do is you can show the download code. So when you show the download code, you will get this snippet, and this API key will be specific to you. Okay, so you have to copy it using this copy button which was shown here. Okay, so this is my API key. When you work on your RoboFlow, you will get your API key. Now, what is the use of this? Okay, so this is, I hope everybody is clear with this concept of RoboFlow, because it's going to be very interesting when you use it actually. And I'll also show you that how it looks like when you are downloading the zip on your computer. Now coming to the Google Collaboratory notebook that you have. So this is again another API key which was used in the project for this API key is from another project that was created on RoboFlow, right? And when I run this, so now you see what happens. So nobody. Okay. Let me just, I think it didn't get run again. Okay. So now you will see what happens when I download this my API. Okay. This is what I downloaded from your this RoboFlow, right? So all the images which were there, I can see here. And the labels, the bounding boxes that were created, those annotations have been stored as txt file. Just a minute. Okay, sorry for the interruption. Right. So when I see this, you can see there's this folder called underwater object detection. Okay. So this is the one that was linked to this particular API key, which is there on RoboFlow. So now you can see that the data set is there with me. It has been divided into training set. Okay, we have the images there, the validation set, and the testing set. So everything has come here. Whatever images were there, they were annotated. Okay, and there were certain classes in that which we wanted to classify for objects which are there underwater. Okay, so that all has come here when I connected to RoboFlow using the API key. Now, what is a model that I want to use? Now, you see here there is this command, this function YOLO, where I've given this path of YOLO v8.yaml. So this is something, these files, if you identify the files which are present in the Ultralytics folder that I showed you at the beginning, so you will be able to find everything there. So all the configuration, everything. So I have to import YOLO basically from Ultralytics, and then I can proceed. Okay, so basically YOLO scale is also there, small model, medium model, large model. As I said that this was introduced in the 4th or 5th version of YOLO. So it has taken it as the normal scale. Now what I want to do, now I want to train my model. Okay, and for training my model, we have to basically use this task, okay, where I will be able to detect, and for prediction of the object, there is this predict task, and for detection where we are actually training, so we can use this. Now I'll show you how this changes. You can use this command where you use the detect task, or there is another way how you can modify this. So load this model, okay, like here you can load all these files, YOLO world.yml, YOLO a10.pt. These are all present here in your Ultralytics folder only. Now what I want to do is I want to train this YOLO model on my YAML file which contains information about the data. Now, when I run this, there will be a certain thing which will stop me from training. So it is not able to actually find the data set right now. So when you figure out this underwater detection folder, there is this data.yml file. Okay. And this contains the configuration of your data set. Okay. So these are the classes that I have defined while annotating my data set. The number of classes are 8. And I have to basically check this, whether this path is correct or not. So I will just change the path and I will work on it again. So I have to give the path of the images folder, which is there. So I have to give the complete path. And then the validation images, so I have it here. Okay. And for the testing, I have the images folder here. So I'll save it, the data.yml. And then when I run this, so what you will see is that now it is downloading it and the model will start getting trained. The epochs that I have set right now is 3, but you can definitely fine tune it. You can change it to 10, 20, 50, whatever suits your purpose, so that your performance values are good. So now you can see that what is the configuration of YOLO V8 in the normal scale. You have 256 layers, you have around these many parameters, and or everything will be visible, how many layers are there in the convolution layer, attention layer, in the concat layer. So there are all different things. And if you want to check the YOLO dot v8.yaml file, then you can go to the ultralytics folder and there you will get the YAML file for the YOLO V8 model as well. So the training is going on right now, and once it is trained, so again, because the weights and everything are optimized, so we will get this model best.pt, okay, which we will be using because this is the best optimized model, and this we will be using for the prediction task. So whatever model you are getting after training, so you will be using it for predicting, and there you use model.predict and you give the path of this image that you want to test, predict that what is the object which is present in this particular image. So what is the object and what is the category. So this will be possible once this is done. So I've set the number of epochs to 3. Let us just wait and let this model be trained on this, and then you can see the results that how this fares and how you can use it for object detection. So while this is going on, now I will like to know if you have any doubts or if you want to ask any questions. We can save that time and then I will show you the results. Actually, there is no, it is not of much use to copy it here. It is better that you can try out in the Google Colab link only because, and specifically, if you can get your own API key and you can, upload some objects on RoboFlow and you can get your own API key and try to connect, that would be the best thing. Otherwise, if you have, like Dr. Abhishek has already shared the code with you, so you can try it out, but I would suggest that you should, try getting your own API key from RoboFlow, connecting with your dataset, and then following these steps that I have followed for my particular dataset. That will give you a lot of insight, basically. Till then, if there are any other questions, please type on the chat or ask. Yes, API steps I can tell again. So when you go to RoboFlow, okay. Yes, I'll show what type of output will come. So when you go to RoboFlow, you have whenever you're crossing all these stages where you're uploading the data, you're annotating, and then you will get an option where you will be generating and doing the data augmentation and continuing. So then it will train your YOLO model, okay? And once it is trained, you will see this versions tab, okay? So there, go to download dataset and select YOLO V8, show download code. So when you do this, you will get this snippet. You have to copy it and then you have to put it in your collab notebook. So when you will be putting it in your collab notebook, okay, then you will be able to connect to your repository when you are running it. So all the data set that it is connected to along with these labels. So labels basically you have annotated a few bounding boxes, right? So and then categorize that this is the class, this is the particular category. So that all will come in your Google Collaboratory itself in the content section. So that is how you have to go ahead and you have to just paste the code snippet and then you have to run it. You will get the data set, associated data set. Now you will be able to use it in your Google Collaboratory and go ahead. there is no fixed thing that if you are talking about the image dimensions, obviously when you will be working on a particular data set, there will be images which will be of different dimensions, but in general, conventionally, these are taking 640 by 640 size pixels resolution, right? And rest, when you are doing your task, when you are doing, say, even on RoboFlow, you are also cropping the images, you are performing some augmentation and everything. So you are actually doing some kind of augmentation tasks which will change somehow, but yes, obviously it will be consistent whatever the size is going on. It will make sure that the sizes of the images that you are using, obviously they are of a consistent size. Output that will come from prediction that I am going to show you, because my training is still going on. So as you can see that two epochs are almost over, and it has found, as I told you in the beginning, a bounding box loss, classification loss, and it is running for the epochs I have set myself. It is not like, just to show you, I've kept it to be three, but it is better that you are increasing the number of epochs. So it will take time. I will suggest that whenever you are running on Google Colab, you go to runtime, go to change runtime type, and it will be selected on CPU. So I'll suggest that you go and select on T4 GPU. So when you are using this GPU associated with Google Colab, it will be very fast. And if it is selected as CPU, then obviously it will be taking a lot of time. So this is going on fast because I've selected the GPU option from this runtime. Okay. Now, as per the output, see, there are two things. Now, right now, I'll show you one kind of output, but what actually happens is that when you go into deep implementation of this, when you will be running it, so when you go for the prediction tasks, it also gives you a visualization of your image with a bounding box that this is a person or this is a class. So basically, when you use such kind of command also, so you get a visualization of your object, and bounding box there which shows that what kind of class this object is categorized in. So there was some UTF-8 problem for me in this, which I was figuring out. Mhm. But then, meanwhile, to show you the second type of how the object gets detected here, I have used this model.predict and given the path of the image on which I want the model to detect that, this is the object. So we'll just wait for another minute or so, and then we'll see how the results come out.
Ma'am, your voice is not coming.
Is it coming now?
Yeah, ma'am.
So till where did you? Okay, I'll repeat. Okay. So after the training was there, when the training went on, so we got to know that what are the MAP values. Now, what is the difference between MAP 50 and MAP 50 to 95? In MAP 50, basically these are based on the thresholds. So for MAP 50, the IOU threshold is set to be 0.5, and for MAP 50 to 95, the IOU threshold is set from 0.5 to 0.95. So in our case, the MAP 50 values are better for recognizing the objects as compared to this MAP 50 to 95. So both of these metrics, they are helping you to evaluate. And when you see, when this the entire process is done, the results are saved to the runs folder, further detect folder, and then further say it is storing here in train 22. The final results are saved to train 2 weights. So I'm going here in the runs folder. I have detect train, and in train 2, I have the weights folder. So where the weights, the best weights, optimized weights are stored in the PT and ONX format. And then all the results are there with you. Like if you want to see the confusion matrix, you can go ahead and see the confusion matrix for my classes. You can go ahead and you can check the R curve. You can check the right, you can check the results, you can analyze that how the results are coming, and what is how it is differentiating between these different classes that I have set in my for my objects, right? The classification loss, the precision, the recall, the MAP 50 value, the MAP 50 to 90, you can all get that in a graph here from this folder. You can save the weights, the best.pt weights. Now here what I'm doing is, so either you use the predict option, or there is another model.predict method where you can also so there is yeah. So there is a way where you can even visualize your this picture on the screen. But right now, the method that I have used, I'll share the other way also later. I'll share the slides. When the slides are shared, I'll also share the other method of predicting the objects, or I'll share a blog post which is very good. For normal, if you want to visualize the annotated way of analyzing the results, when I'm using the model.predict, I'm giving the image path which I want to test. And here you can see that it has, so again, as I told you, the resolution was 640 by 640, generally, which is used for V8 and V9. And it has detected that there is an army diver in this. Now, for this time, let me go and check whether actually there was an army diver or not. So when I go to the test images, and I think probably this is the first image that I took. So yeah, there is an army diver in the image, and when you want to visualize it, जब ये आप visualize mode में देखोगे, so it will have a bounding box also around it, जिससे आपको उसके coordinates भी पता चल जाएंगे. So that I will definitely share. But right now, as you can see, कि अगर आप इस तरह से भी model dot predict करके results में store कर रहे हो, so it is able to tell you that there is an army diver, an object has been detected in the image, which is an army diver, right? So this is how actually the entire flow is going on. And even when you are doing this on RoboFlow, so even on RoboFlow, what happens is that you can try out this model, and no, that is based on a particular. There is also another place where you can upload and an image and see whether it is coming out to be correct or not. So like here you can select, of course this RoboFlow model of mine is not very having a good MAP, so it is not going to work very well for me. But yeah, you can even upload an image or video file here, and it will show you that okay, what category it is classifying it into, the object that has been detected in the image. So this is how it is going on. And so this is how it is going on, and this is the entire flow of YOLO, whether you are using on RoboFlow or you are using on Google Colab. but this is how you can link using your API and everything, and you can come to the final decision that what all objects, even if more than one objects are getting detected, it will detect. So this is not that it is only going to classify an image as a particular category. Whatever object is, even if a dog or a person is together in your image, it is going to detect it. Okay. So, right. So this is how this is going on. Now, please ask your queries. You already have the notebook, right? This is a good lot of work to actually try today and understand the working of YOLO. And once you do this all, you'll have a good hands-on and deep practice of this. So somebody raised a hand. Anybody wants to ask? Yes, Neeta, please go ahead. Dr. Abhishek, I'll leave the last 10 minutes for any discussion or questions that there are, if there are. Yes, please go ahead.
Okay, ma'am.
Sir, if you permit me, then can I
You can
discuss
ask.
just 2 minutes, sir? Ma'am, my question is just I was discussing about the segmentation. So
Correct.
first thing is for classification, I don't think so. Segmentation is necessary, but still, if I want to do segmentation, is mask is necessary for that? My second question.
Yeah, that's right. There is no need. It's not necessary to do segmentation because when you are using deep learning and all, it is going to extract your features from the image, right? But
Yes.
how semantic segmentation will help you? It will help to improve actually because when you will be already segmenting your image based on the boundaries or the masking, or you are separating two regions where different objects are present, और उस हिसाब से आप लेबल कर दोगे, then it will have an impact on the performance or accuracy of your model. That is the advantage that you will have.
Yes, ma'am. My approach is just I want to extract only the infected part of using the segmentation. Then I will apply some other technique. That's why
So that
I want.
data set, क्या आप मेरे को वो like can you after this session can you mail me 2 or 3 sample images from your data set
Ma'am,
ताकि
you
उसके
can
ऊपर
think
जो,
about the plant village data set, just like that.
but what is there in that plant and all, क्योंकि infected disease है अगर, so how is it
Yes,
showing कि वो disease है उसको, मतलब it is infected, वो आप कैसे पता कर रहे हैं?
so that is annotated, ma'am, already annotated with some person's agriculture officer that is already identifying and labeling this one. Okay, this
So then
I
it also
segregate.
depends कि अगर वो already annotated है तो हो सकता है कि आपको segmentation की जरूरत आगे और पड़े ही ना. That is also possible.
No, मैम द रीजन वी बिकॉज द आपका बहुत कम छोटा पार्ट ही मतलब इन्फेक्टेड है उस केस में जस्ट आई वांट टू
Hmm.
अवॉइड द ग्रीन पार्ट ऑफ द इमेज सो जस्ट इफ वी फोकसिंग ऑन द ओनली द इमेज दैट इज इन्फेक्टेड पार्ट देन माइट बी पॉसिबल कि एक्यूरेसी कुछ इंप्रूव हो जाए दैट्स व्हाई आई वांट
कि
वो
मतलब यू
मोटिव
फील कि अगर आप उसको सिमेंटिकली सेगमेंट कर देंगे तो आपकी जो एक्यूरेसी है वो थोड़ी सी इम्प्रूव हो जाएगी. दैट इज व्हाट योर इंटेंट इज बिहाइंड इट, राइट?
यस मैम
ओके ओके. सो
So for
द
that,
पॉइंट
I'm
अगेन
asking
इज,
masking. I think for semantic segmentation, yesterday Madam was discussing about the dice coefficient. So for that, I think a mask is necessary to calculate the loss. That's why I'm asking this question.
फॉर मास्किंग यू आर आस्किंग, राइट? कि आप मास्किंग अगर करना चाहते हैं तो फिर आप किस मेथड से कर सकते हैं, इज दैट?
Yes, that's my intention is segmentation. But yesterday the method is discussed in that dice coefficient was calculated. In that case, you require the mask already. If you have the
गॉट इट.
mask, then you can calculate.
गॉट इट.
So I'm
लाइक
asking for the segmentation. Is it necessary to have the mask, or without masking it is possible semantic segmentation?
सी, वैसे आइडियली मास्किंग विल बी हेल्पफुल. मैं भी सजेस्ट करूंगी कि गो अहेड विद मास्किंग. इट्स
Yes,
नॉट
ma'am.
ओनली like dice coefficient is one of the methods. You can also go for, as I said, morphological operations, जैसे binary masking कर दी. उसमें आप पिक्सल्स के ऊपर काम कर रहे हो. सो जो पिक्सल्स आपके इन्फेक्टेड वाले हैं वो आपके मास्क आउट हो जाएंगे या वो हाईलाइट हो जाएंगे, राइट? जैसे हम इरोजन डायलेशन बहुत बेसिक ऑपरेशन हैं, बट अगर हम मास्किंग की बात करते हैं तो कुछ कलर की बेसिस पर भी मास्किंग हो सकती है, ताकि आपने कलर पिक्सल्स को फिल्टर आउट कर दिया, या आपने कुछ थ्रेशोल्ड रख के उस बेसिस पे आपने मास्क कर दिया. So I think that will be helpful for you if you go ahead with such kinds of methods before classification. तो
मैम
वो आपकी जो
बाय
फीचर एक्सट्रैक्शन है उसको इम्प्रूव करेगा.
मैम एक्चुअली जो इंटेंसिटी दैट इज यूनिफॉर्मली डिस्ट्रीब्यूटेड, उसमें आई डोंट थिंक सो कि जो इन्फेक्टेड पार्ट है वो कितना, उसका इंटेंसिटी कितना है, ग्रीन पार्ट का दैट कुड बी द सेम. उस केस में अगर बाइनरी पे हम जाते हैं तो इट इज वेरी डिफिकल्ट टू सेग्रीगेट बोथ पोर्शन, क्योंकि मैं करके देखा हूं, पूरा ही फिर इमेजेस दे रहा है, मतलब पूरा ही उसमें इन्फेक्टेड भी आ रहा है, नॉन इन्फेक्टेड भी आ रहा है.
The
तो मुझे
color
तो
part
बस
is the same. That is not like going to help you. Color pixels उसके हिसाब से आप नहीं कर पाएंगे, right?
यस मैम, एग्जैक्टली इंटेंसिटी, जो इन्फेक्टेड पार्ट की इंटेंसिटी कितना है दैट इज डिफिकल्ट टू फाइंड आउट. और वो हम विजुअलाइज कर सकते हैं, बट इनसाइड कंप्यूटर में हाउ वी कैन कैलकुलेट एग्जैक्टली कि कौन कौन से पिक्सल दैट आर इन्वॉल्विंग
तो
इन
फिर
द.
आप एक काम करिए, आप मेरे को मेरी ईमेल आईडी पे आप 2 या 3 कुछ सैंपल्स नॉर्मल लीफ के और इन्फेक्टेड के आप मेरे को मेल करो, ठीक है? तो मैं
ओके
आपको उस अकॉर्डिंग सजेस्ट कर दूंगी कि आपको सेगमेंटेशन के लिए कौन सा बेस्ट मेथड है जो आप यूज इसमें करेंगे तो अच्छी एक्यूरेसी आने का चांस है. सो you can just do that
Yes,
and then let's take the discussion further
yes,
कि
ma'am.
उसमें कलर की जगह क्या अच्छा रहेगा.
ओके ओके.
Thank you very much, ma'am, for joining this session, ma'am.
Thank you so much for having me, and I look forward to like discussing all this further for these interesting discussions on object detection and classification. And thank you, Dr. Abhishek, for having me here.
Thanks, ma'am. Dear.